Hey, good morning, guys and persons and folks. We're going to be talking about ISO 31000 and risk-based decision making. So, golly, I'm assuming that we're all from quality land or from reliability land. So if you've got questions, please pass them along. I'll stop or I can answer them at the end of the talk. So anyway, thanks for being here, and hopefully you have a chance to learn something. So let's dive into it. If I can punch the right button. So our agenda today is why does this talk matter? One of the things that I've been playing with for almost 2 years is ChatGPT, and we're going to talk about AI and why that's going to change our profession, as well as change the value add that we have for companies. Second thing we're going to talk about is how our profession is being disrupted, both quality profession and, quite honestly, almost all professions. We're going to talk about critical terms in risk and decision making, and then we're going to do a deep dive into the standard 31000, which is the risk management framework that ISO came up with in 2018. Actually, the predecessor was probably about 8 years before then. And then we're going to talk about lessons learned, and that's a picture of me on the right. So why does this talk matter? Quick story, and it's a story I share a lot because I think it's got a lot of profound impacts. If you've got a smartphone, you've got access to almost all of the information in the world in your smartphone. All you have to do is ask Siri or Alexa, and boy, it'll just simply give you an answer, very intelligent answer these days, to almost any question. And that begs the question, what do you do as a professional, quality professional, engineering, or even quality, when all the tools, all the knowledge for your work, career, and job is available on your smartphone? What's your value add going to be? What's your competitive differentiator? Why should somebody hire you as an engineer, as a reliability engineer, for example? So right now, Alexa and Siri, or frankly, any GPT item, has access to all the world's information. But now, not only does it have information, it has how-to directions as to how to do something. So a quick story. Last couple of years, we've become a software shop. So we use low-code, no-code tools to develop our software. It could be an app, it could be almost any type of product, but right now we're focusing on apps. And it's interesting. When we were coding, just simply line by line, it would take us X amount of time. Because of ChatGPT, well, okay, I'll give you the numbers. So let's say just simply do a hard coding, meaning line by line, it took X amount of time. We then went to a low code system and our efficiency went up 10x. Then we went into a no code system, no software coding, and our efficiency increased 15 times. Now we're using ChatGPT to do our coding, and we've got various repositories that it refers to, and our efficiency is probably 20x to 25x. Unbelievable. And by the way, that's just an example how AI, or what we would call generative GPT, is really changing everything we do. And all of that now is going to be available through our smartphone. So the question we've got to ask is, what's your personal differentiator value add going to be? But now, not only can we get information very quickly through the smartphone, but it can give us process details. In other words, tell us how to do something faster, better, more efficiently. And that's going to be the challenge. And that's hopefully the question I'm going to be answering in today's talk. So let's talk about the disruption going on in the quality profession. And by the way, this disruption is happening in every profession. And also you can extend that to, it's happening to every job description or function. And it's also happening in careers. Now, we don't know what's going to happen yet in careers, but we can probably figure out that when I joined the workforce, I could probably get a job for 10, 15 years. Now, I think the numbers coming out of the federal government are, we're going to have 6 or more different careers, not jobs anymore, careers during our lifetime. So I'm just going to talk now about some of the disruption that's happening in the quality and reliability profession. So a big challenge for us in the quality profession, and probably reliability, is risk is becoming dominant in a lot of the standards. ISO standards, IEC, almost all the standards have some element of risk in them. And that's the problem. There's a multiplicity, there's a whole bunch of definitions as to what risk really means. Second problem about the different risk definitions is the methods to apply risk are all different, meaning manage risk, treat risk, control risk. The third issue, the challenge in these standards are, many of the standards are verticalized, meaning they're particular to the knowledge domain. And the way you apply risk management is essentially different. And when you go to a lot of standards, they don't tell you how to do something. All they do is they offer you guidelines. And the difference between a shall, which is a should or a need or a requirement, and a guideline is, what do you want to call it? It's optional. You can either apply the guideline according to what's written down in the standard, or your best interpretation of the guideline is often good enough. So that's the first big challenge in our quality profession about risk. Now, again, risk is being implemented at least in all the ISO standards, but it's happening in ANSI, IEC. It's the dominant standard, for example. Risk is the dominant feature in all climate change standards. It's the critical determinant or criterion in all of the AI standards right now, which, by the way, are being developed.
Hey, Greg.
Yeah.
Carl's asked a couple of questions there. Maybe I want to touch on, because I think it's in line with just the amount of change that's going on. And it says, so we're all in information and overload. And then he followed up with, and we need to keep adjusting and evolving. And then I think the capper here, Carl asked, will we ever have a risk-free society? And she just added another one. The guidelines are not etched in stones. And you just mentioned they keep evolving and changing. So how about risk, liability, statistics, all that stuff? So Carl's got a kind of a short list here for you.
Yeah, this is one of the misinterpretations that a lot of people have. I'll just talk about AI right now, because right now a lot of standards are being written in artificial intelligence. And the layperson, meaning the the public policy person or the legislators, they think there is such a thing as absolute assurance. There ain't no such thing. There is always, the best we can do is develop a relative assurance, or basically relative risk controls. There's still going to be residual risk. Now, the question is, with a residual risk, what is acceptable to you or to the organization? And what's happening is most organizations do not want to declare what residual acceptable risk is. Why? Because if they know it, they have to control it, And they can't hide behind the fact that if I didn't know it, I'm not legally liable. So there's a lot of issues now and a lot of misinterpretation about risk and how the standards are written, because there's always going to be uncertainty. There's no such thing as absolute assurance. And what's acceptable, meaning residual risk or risk appetite or risk tolerance, is often not defined. And if you don't define those concepts, you really can't manage risk. Or also, there's a lot of misinterpretation about, can people actually manage uncertainty or volatility or complexity? You really can't. You're always going to have controls, and then the residual, what's left over, is that going to be acceptable to you or the organization? And people don't want to define that, quite honestly. So anyway, what's the other question?
Well, part of it, you start off with really the pace of change and information overload and that kind of thing. It made me think of back to Future Shock from Alvin Toffler,
Yep.
which was in the 70s. I don't think we've changed at any from the rate of change. It's just the rate of change. And, you know, I like Carl's that we just need to adapt. And that's a, you know, and we don't have a whole lot of choices on that.
Yeah, in risk land, that's called adapting, is called risk acceptance. And we're not ready to even define what risk acceptance is, you know, whether it's climate, forest fires, flooding. So there's a lot of debate going on. Also, right now, the big thing is climate change and AI, artificial intelligence. The rate of change, the delta, you know, the delta T, well, yeah, the delta is just simply happening too quickly. But please, yeah, stop me, ask the questions, and I'll try to provide more perspective, because there's a lot of stuff here, and I'm going to be covering hopefully common sense detail. Also, I'm taking the standard ISO 31000 and providing hopefully some personal examples for it, because part of this reasoning for talking about this topic is we need a common taxonomy. We need a common way to look at risk. And these RMFs, risk management frameworks, at the end of the day are just simply a common rubric, a common way, common methodology, or a common, even, what do you want to call it? Common context to even discuss uncertainty. So another disruption that's occurring in the quality profession is this concept of risk-based thinking. Now, why is that important? In 2015, 7 years ago, ISO brought this concept into the standard, ISO 9001, 2015. Only one problem: they never defined the concept. They never even really discussed how to implement it. So in the meantime, just imagine, we have over 1 million companies worldwide certified to ISO 9001. And we got this concept called risk-based thinking, but it's never defined. Big problem. So the other thing we're going to talk about is the future standards development. And standards, by definition, is something that we basically comply with or adhere to or basically move towards. It can be a best practice. It's something that we have to do, like it's a shall requirement. But what's happening is that these standards are being written either at the lowest common denominator, or you have to interpret them as a guideline, or there's very little rules and regulations as to how to apply them or how to comply. So basically, our profession is being disrupted. And I'm going to talk about this in a little bit more detail, and I'll provide some examples. So here's the definition of risk in ISO 31000. Is the effect of uncertainty on objectives. Now, this is a direct quote. Now, what's the problem? First of all, your objectives in the organization have to be defined and they have to be clear, preferably SMART. Second is when you basically take these 5 words, effective uncertainty on objectives, and parse them, meaning break them down syntactically, it does not make sense. First of all, you have an objective, and the objective is written down and it's defined. Once it's written down and defined, there's no uncertainty. It's defined. We know what it is. But that's the problem. The effect of uncertainty on an objective is it's not an oxymoron. It's just simply you can't apply that. And the question is, how do you basically operationalize that definition? You can't. So what we've done, yeah, we've given lots of talks on this all over the world, is we basically want to operationalize the definition. So how do we define, and how do most people define risk? It's the effect of uncertainty on the achievement. You see, an objective is not variable. It's stated, it's an attribute, it's declared. But the achievement of the objective is a variable that has uncertainty. Now, again, I'm playing with the language, but in this world of risk, in this world of certification, where millions of companies literally have to comply, these things can create problems, and they do. And I'll bring up a couple more examples as we talk about. The other thing that's happening in our profession, quality and reliability, is ISO, the standards developers, they put in this concept, risk-based thinking, and never define the concept. Why? Now, why is the problem risk-based thinking important? Well, it's in a standard. How do you audit? How do you comply with somebody's thinking? Quite honestly, if you haven't passed Mind Reading 101, you're not going to do it. You're not going to apply it. You're not going to operationalize. And you can't operationalize somebody's thinking. You have to have an audit trail. You have to have evidence. You have to have facts. You have to have data. You have to have something there. So a third party, second party, first party auditor can audit. Now, why is it not important? Because it's risk assurance. We need to know that our controls, whether we're using a risk language, we're complying with a statute, complying with a standard, we need to have an audit trail. And thinking just simply does not provide the requisite level of assurance for an audit trail. So what we do, and what we've advocated for probably 7 years, is we look at risk-based thinking and break it up into 2 elements: risk-based problem solving and risk-based decision-making. And in today's talk, we're going to focus on the decision-making, because if you have an audit trail and you do risk-based decision-making, you write down your assumptions, you write down how you decide to decide, and you have an output. Therefore, you have an audit trail. If you have an audit trail, you have risk assurance. I hope that makes sense. The third thing that's disrupting our profession right now is the future of standards development. Now, I'll use 31,000 as my example, but I've got others as well. 31,000 is a guideline. It's not specifically not a standard that you certify to. A guideline, again, is a best practice. It's a should, but it's not a shall. And here's the problem. It specifically states it's not used for certification. It's not used for third-party audits. It's not used for a high level of assurance. It's just simply a taxonomy. It's just simply a guideline. And that's the problem. How do you basically use this document, ISO 31000? Do you use it as best practice? Do you use it as a common language? Do you use it for decision-making? How do you use it? Well, here's the challenge. The world's largest certification bodies are issuing ISO 31000 certificates of conformance. And they're doing that worldwide. And some of them, and the reason why they're doing it is, one, customers want assurance. Assurance means certification, and certification means you have to have a standard, a shell standard, that you're forcing companies to adhere to, and then a third-party auditor can assure it or audit against it. But what's happening is the CBs, certification bodies, consultants all around the world, millions of them, need a new revenue model and you need new certs. And here's an example where 3 of the biggest certification bodies in the world are basically issuing conformance certificates. And in this case, we have BSI out of the UK, probably the world's biggest standards body. We have TÜV out of Germany, and we have AENOR out of Spain. They're basically issuing certificates of conformance against the requirements that are stated in ISO 31000. ISO 31000 specifically states, you shall not use this for certification. In the meantime, nobody likes to have an unhappy customer. And
Well, let me jump in here, Greg, before we get another step. Mark mentioned that, risk and opportunity were introduced before ISO 9001. For example, in ISO 55001, asset management, and I don't know what ISO MSS model is, but 55001 is dealing with asset management. And I know that they incorporate, what's the risk to your production if this piece of equipment goes down? Are you talking about the same kinds of elevation and use of risk and uncertainty? Or is this really just an evolution of stuff that's been around for years?
So a quick story. And this is, by the way, happened this week. Every 7 years, the standards, all ISO standards are updated. Every 7 years. That's their cycle, their redevelopment cycle. So ISO 9001 was developed in 87, 94, 2000, 2008, it was updated, and 2015. So last year was supposed to be updated again, 2022. But the world standards bodies voted 6 times not to update the standard. In the meantime, the folks at ISO said, no. We have too much misinterpretation. We have too much misuse. And the 3 areas of misuse, actually 4 areas, are 1, the definition of RBT, risk-based thinking. The second area of misuse is the definition of risk, which, by the way, includes upside opportunity risk and downside consequence risk. And they wanted to clarify that. The third thing they wanted to do, meaning ISO, is they wanted to incorporate climate change risk into the standard. And that caused huge turmoil in the world. So the world standards bodies, and when I say standards bodies, it's US has a body, Germany has a body, Mexico has a body. They voted 6 times against updating the standard. Well, ISO forced them again this week to vote again, and they're going to update the standard and clarify upside risk, which is opportunity risk, and downside consequence risk. Again, more and more uncertainty. And what happens is when you have uncertainty, you have variation. When you have variation, you have nonconformities. And when you have nonconformities, you don't have risk anymore. Because the key term, the key concept in reliability, the key concept in quality is what? Consistency. Consistency in interpretation of the standard, consistency in the application of the standard, consistency in the assurance of the standard. If you're missing those three things, you don't have a quality system anymore. You don't have a reliability system anymore. Another way to think about that, and I'll try to simplify this, is 3 questions have to be answered to ensure consistency. Do you have the right standards to which you're going to evaluate? That's the what question. Do you have the right standards against which auditors are going to evaluate or consultants are going to apply the system? Second question that's really critical is how to. Do you have consistent language to apply, to determine, to solve a problem? The third thing is, do you have the right people, the who? Do you have people who have the right skills, abilities, and qualifications? In the meantime, for those 3 questions, what are you going to audit against? And what are you going to comply against? What's the standard? 2, how are you going to do that? How are you going to apply it? And 3, who? Those 3 questions are variable. And if you have variability, you don't have consistency. If you don't have consistency, you don't have quality and reliability. So that's the back to the question about upside risk. A lot of people around the world have never heard that before. Why? Because 99% of us interpret risk in terms of downside likelihood and consequence. I hope I answered the question, but that's literally being debated right now globally.
There's a couple other comments, but I think you're going to be diving into the structure of 3100 a bit more. So I think you're going to cover them there. So I'll acknowledge there's a handful of questions. I'll keep an eye on them if you don't cover them, Greg.
Okay. Because I've got a lot more. Yeah, give me some more time.
All right.
Because I'm 26 minutes into it and I've got a lot more stuff. But yeah, these are all great questions. I'll answer them. So let me define risk. The risk definition of 31,000 is missing the uncertainty of achieving objectives. The definition of risk management itself is a little bit variable. And again, if you have variability in anything, you have lack of consistency and you don't have quality. So I'm going to talk about decision making, because remember, our definition of risk-based thinking is risk-based problem solving, risk-based decision making. And if we don't have that type of consistency and documentation and data, we can't implement the standard. And remember, the 3 questions that we need for anything, and it doesn't matter if it's engineering or if it's quality or reliability, we have to have the what, we have to have the how to, and we need to have the 3. And we need them consistent. If we don't, we're not going to make good decisions. So big questions for you I'm going to ask is, do you know how you decide, both individually and for your company? Because going back to this thing, and I've got my little iPhone 13 in my hand. My iPhone 13 has got all the data in the world. Because of GPT, now we know the machine now knows how to implement that and knows the how to. So what's your value add going to be? At least for the next 5-10 years. I think your value add is your ability to make good decisions. And we'll discuss good in a couple minutes, because that's what ISO 31000 is. It's really a way, a framework, a rubric to make good, consistent risk decisions. So first of all, what's a framework? A framework is just simply an architecture. PDCA, HALT, all those are frameworks. Mean time between, mean time before, all those things, they're frameworks. In reliability, most of the frameworks are at the transactional or product level. PDCA, Plan, Do, Check, Act, is at the process level. And then our framework that we're going to be talking today can be used largely at the process or enterprise level. And that's important. Probably in November, next month's talk is in September is going to be context is worth 20 IQ points. In October, I'll probably talk about decision making. But anyway, think of it in terms of the application of a framework. We're going to be talking about a framework in terms of decision making at the process level. And you can think of a framework as a set of controls. What type of controls? Risk controls. So I'm conscious of time. I've got my little timer in front of me, so I'll go through this quickly. The other thing in terms of a framework is it follows a logical cycle. And again, the big cycle that we know in quality and reliability is PDCA, plan, do, check, act. Now, why is this famous? Well, it's a 4-step model for change. And most, if not all, ISO standards are based on this model. And we'll talk about maybe in November why plan, do, check, act doesn't work too well in risk and in AI, but that's another talk. So anyway, we're going to have some fun with these things. Here's the model, ISO 31000 model on the right. As you can see, it's got it's got about 8 elements to it. And we're going to talk about each one of the elements in detail over the next 10, 15 minutes, and then we'll dive into your questions or comments or editorials. So the first one, and I've got a big red arrow pointing to the box. Again, this is a process. As you can see, it follows a cycle. Second is an RMF. It's called a risk management framework. If you're not familiar with that concept, RMFs, you're going to see a lot of that now in almost all standards. Why? Because all of the standards in the world coming out for artificial intelligence, climate change, ESG, are all going to be RMF based, risk management frameworks. So make that part of your vocabulary. So in this part of the standard, and again, by the way, this is an RMF that is used for decision making primarily, and that's what we're going to talk about today. Why do we want to use it? It's consistent. It has a common taxonomy, a common definition. Think of it as a way to solve problems or to make decisions. It also is a way to demonstrate due diligence. It's a way to set up a common language for problem solving, a common language for decision making. In ISO land, it's a common way for GAIN certification. So in this step, the first step, and I've got an arrow pointing to the box. Here we answer a couple questions. Who are the stakeholders? And do the stakeholders have the right information at the right time to do what they want to do or go where they want to go? And finally is, are we solving or are we trying to solve the right problem? So that's the box where we look at those 3 problem-solving issues. Context. And that's what I'm going to talk about next month through Ascenda. I'm going to talk about context or understanding it is worth 20 IQ points. I'm going to basically spend an hour either justifying or defining what that really means. If you don't understand the context, you don't understand the problem. If you don't understand the problem, no solution or any solution will work. Doesn't matter if you're doing reliability, doesn't matter if you're doing life cycle testing. If you don't understand the context, you don't know what you're doing. That's the bottom line. And I'll try to answer that in more detail next month. So in this way, in this box here, what we're really talking about is, do you know what problem you're trying to solve? Do you know why the stakeholders want that problem solved? And what's the scope of the problem? It's a big issue right now in ISO, whether it's almost any ISO standard, whether it's climate change, whether it's energy, whether it's manufacturing. Scoping the problem is a big issue, because what I'm seeing is that people are using these tools out of context. People are answering the wrong questions, or they're trying to boil the ocean. So it's really important to understand the context and the scoping and the assumptions of the problem you're trying to solve or the decision you're trying to make. So the next part, as you can see from the thing on the right, most people, 90% of the people, think and use the term risk assessment and risk management and risk treatment and risk controls simultaneously. I mean, I'm a geek. I parse the language. To me, definitional control for what are we auditing against, or what are we doing, and how are we doing it, and who should do it, to me are really predominant issues for problem-solving decision-making. So risk assessment is really three areas. It's identifying the risk, analyzing the risk, and evaluating the risk. Risk assessment is not risk management. And unfortunately, a lot of folks tend to use the terms risk assessment and risk management interchangeably. They're not. Risk management is really this whole framework. Risk assessment is only those three things in the middle boxes. So identify the risks. It's really critical to identify the risks in terms of the organization, the enterprise. Then at one level lower, programmatically, project and process. And then at the lower level, in terms of transactionally and product based. Most reliability problem solving is at the product level. A lot of quality is at the product level or transactional level. And here's the challenge. The risks at the enterprise level can be diametrically opposite in terms of how to solve them, how to mitigate them, how to treat them, than at the lowest level, at the product transactional level. So identifying risks. Risks essentially are the obstacles or the things in the way of meeting your objectives. Risks can be people, process, or technology based, and it's important to look at them at the enterprise, programmatic, and transactional level. Next part is analyzing the risk. And analyzing risk is looking at the risks in terms of reliability, cost, and schedule. Basically, a risk can be anything that is a variable in terms of an objective. So if your objective is to have zero cost deviation, if you have a cost deviation that's 10% above or 10% below, that's a risk. Now let's look at the cost as an example a little bit more. You basically have an objective. You want to have zero variation. So if you have 10% below your target, that's an advantage. That's an opportunity cost. Why? Because you're saving 10%. But on the other hand, if your cost overrun is 10% over, that's a risk consequence. That's an example of both positive and negative type of risk. So at this stage here, you're evaluating risks. And the risks can be, again, variability in terms of your reliability target, quality target, cost target, or schedule target. And again, you can evaluate risks in terms of likelihood and consequence. Now, most risk analysis is what we would call qualitative. Quantitative risk analysis is what can get very, very complex. And I'll give you an example. We're developing an app called the AI, Artificial Intelligence Risk Management Framework app. We were going to have Bayesian analysis on the front end, and then 3D vector analysis, meaning three-dimensional vector analysis on the front end for decision-making. We did beta testing to our users who said, hey, I don't need this. This is simply data and overload. And I said, what? Bayesian is really good. It's deterministic, it's correlative, it's an attempt to be deterministic. What's the problem? Too much data, too much detail. And oh, by the way, I use my gut. Okay, we backed off. Then we went into 3D vector analysis, advanced calculus analysis for decision-making, risk-based decision-making. We went out to a couple of universities, Oregon State, a couple others, and said, hey, would this add value to you? Nope. So what we found is most people, when they do decision-making, they look at the numbers, but at the end of the day, they rely on their gut. And for a lot of it, it's okay. So when you're doing risk analysis and you're doing it in terms of likelihood or consequence, that's good is good enough. You don't have to go into more detail. If you do, there's a point of diminishing return. It's really important to understand where that is. And I'll discuss that. So in a way, you evaluate risks. And this comes down to your risk appetite. And this is one of there are two big problems with this ISO 31000 standard. The two big problems are, well, I'll bring up three of them. They define risk incorrectly. Remember, we were talking about uncertainty on objectives. It should be uncertainty on the achievement of objectives. Second problem, they don't incorporate that definition of risk into the standard. Third problem with the standard is ISO 9001 and the other ISO standards are not linked. They're not mapped to this document. The fourth big problem to the standard is they do not incorporate risk appetite. This is where risk appetite should be. And when you're doing risk management, if you don't define your risk appetite, you can't do risk management. That's the bottom line. You'll have consultants tell you, yeah, you can do this. You really can't. This standard here does not define risk appetite. Now, in the update that they're discussing right now, they're thinking of putting in a box that says risk appetite. We'll see if they do. They should, by the way, but they don't. If they don't, it's a big, big minus for the standard. And this is another problem for organizations when you apply risk management. Your bosses and organizations don't want to define the risk appetite. Lots of reasons. Basically, the reason is if you're a VP in an organization or an officer and you see a risk, you are legally obligated to manage the risk and define what's acceptable to the organization in terms of your risk appetite, and then report it in your 10Qs and 10Ks to the Securities Exchange Commission. You can't hide behind that. And then when you're aware of a risk and you don't control it, you become legally liable and you have no defense in court. So corporations, companies, bosses don't want to define their risk appetite. And here you have a decision point. You can basically stop your risk management at this point if the controls and the risks that inhibit you from meeting your objectives are within your risk appetite. You can stop. You don't have to go any further. You don't have to treat the risk further. You don't have to go to the other boxes. You can stop right now. But here's the problem. 95% of the organizations do not define their risk appetite. And that's a problem. You can't have a risk management program. So treat risks. Treat risks is the same thing as managing your risks. It's the same thing as controlling your risks. And of course, there's four types of risk management: risk reduction, risk acceptance, risk avoidance, and risk sharing. That's another talk, and I'll probably give that in November or December timeframe. As a matter of fact, I gave that talk last month in terms of supply chain risk management. So if you Want more information on those 4 ways of managing risk, go to my talk last month on SCRM, supply chain risk management, and you'll get lots of information. The next box is who needs to know what, where, and when. That's what this box is about. What do your stakeholders that we defined in communication and consult, what do they need to know, what, where, and when? Why? Because at that point, they can do post-action. They can do CAPAs, they can do reliability tests, they can basically act on what they know. And let's see, the next part is called monitoring and review. Monitoring and review is just simply assurance. Assurance that the objective has been met, that the risks are within the risk appetite of the organization, and basically the organization's in control. Another way to say that, if your organization's in control, you have processes that have been defined, they're stable, capable of meeting requirements, think CPKs, and they're improving, meaning variability is being controlled. Again, if you don't have answers to those 3 questions, what, how to, and who, you're going to have variability. If you have variability, you don't have controls. If you don't have controls, you have risks. If you have risks, you don't have a framework, or you don't know what you're doing, or you're not managing and making good decisions. So at the end of the day, it's really managing variability. So this is critical that to answer this. What's the level of assurance that you need in the organization? What's the level of assurance that you need as a decision maker? Again, there's no such thing as absolute or 100% assurance. Are you comfortable at 70% certainty to make a decision, 80% certainty? Anyway, that's another talk. But so lessons learned, we've got a couple minutes. We've got 15 minutes for questions. Lessons learned. How do you make decisions? Do you know how you decide to decide? What did you learn today? Hopefully you learned something about RMFs and ISO 31000. What are your next steps to become a better decision maker using risk management? Because at the end of the day, I think all decisions in this time of uncertainty are going to be based on risk. Almost all of our value as professionals, quality professionals or reliability professionals, is our ability to make good risk-based decisions. So anyway, here's a recent book I wrote on personal decision-making. Came out about a month ago. Take a look at it if you have a chance. Anyway, that's it. I'll take your questions or comments now.
Well, one of them, Greg, thanks. It's Carl's asking, when you were talking about risk appetite, and I didn't catch it either, is where you define that. And he said risk appetite and risk tolerance. What are the difference? What's the difference?
Very, very good question. Now, people use these interchangeably. Risk appetite is a term for risk at the organizational or enterprise level.
But Greg, is when you're talking about, I'm going to use the specific example you use. It's like cost. If it's 10% above or below, then you say, hey, that's a problem either way. Is that if I had a lower appetite for risk, the amount of risk I'm willing to accept, I would say that's plus or minus 5% instead. If I had a larger appetite, I'd say plus or minus 20%. I can deal with more variability or less, depending on my personal preference to some degree. Is that what appetite is?
Let me pose that question. Let me reframe that question for a second. Let's say you're a large company, a billion-dollar company, and you make decisions. Let's say $1 million decision about approving a project. Basically, that's called not a material issue. So at the enterprise level, material issues that are reportable, dealing with risk appetite, meaning a company is willing to lose $1 million, is not material. If it's not material, it's not reportable in your financial statements. Well, so that's the criterion for appetite at the enterprise level. If there's a risk of $1 million and you don't have to report it to the regulatory authorities, it's not significant. If it's not significant, it's not material. If it's not material, it's not reportable, and that's your risk appetite. If it's a $10 million investment that you're doing in $1 billion company, and that will impact your financial statement, then that becomes your risk appetite, because that becomes reportable.
So the appetite is defined by the regulatory oversight body of some sort,
Yes.
is what's material.
Now, at the project level, when you say 10% above or below your target, that becomes your tolerance level.
Yeah, okay.
Now, I'm becoming a little bit what I would call squeaky in terms of my language. But a lot of the language of risk is regulatory. And it's important to understand that as you get more involved with risk at either the enterprise level or at the project level, it's important to have a taxonomy, or in this case, an RMF. And that's why the RMF is so important. Because if you are making decisions that have dollar impacts, then you basically have to defer it and be able to answer the how-to question. The how-to question is, you want to defer to a standard, in this case, 31,000. If you're going to defer to a standard, 31,000, for example, you have to make sure that every one of the boxes in the standard is being addressed for your due diligence. If you're not basically answering the how-to question. If you're not answering the how-to question, you're going to have variability. If you have variability, you have a risk.
I think part of my confusion, and this is building on Carl's comment, is that
Sure.
you said the standard doesn't address appetite, yet the regulatory bodies like the Federal Trade Commission is saying if it's material, that sets your appetite.
Yep.
So it is defined. ISO's not defining it. It's imposed. Yet it gets fuzzy with a private company, right? Except unless the owner sets it for themselves.
The owner will set it.
Yeah.
Well,
they may, and it may be different from month to month, depending on which shiny object they're looking at, which adds another level of risk where the standard really should set it up. The hard part here is that in your discussion on appetite, it's not defined in the standard, even if it is imposed by regulatory agencies. It's being ignored. Is that part of just CYA? They have to say, well, we're doing something to address some of these risks. Is they can't ignore all risks. I think the court of law will say, well, you just can't turn a blind eye to all these things that are a problem, right? So there's a little bit of politics going on, is my impression.
if you're an officer in a publicly held company, meaning a VP and above, you have a requirement, statutory requirement, to basically do your best, or what's called reasonable threshold.
Mm-hmm.
You know, and again, I could spend hours on reasonableness. You know, what does reasonable mean? How do you determine it? Again, that's a legal threshold. In the how-to world, if you're going to set up a company you have certain procedures, certain protocols to follow. If you're making a decision in a publicly held company that has a material impact to the organization, you need to answer the how-to question. Did you follow a procedure? Did you write down your assumptions? Did you follow it? In this case here, did you go through every one of the boxes in 31,000 and do something? That's the definition of good, or what we would call reasonable decision-making.
Right. And so, but
yeah,
you were talking about is if it's not material, then they can say, no, we don't have to deal with that, is the way I'm interpreting that. If they identify a risk and it's like, oh, that's a $10 problem, we don't have to worry about that.
Yes.
Okay. All right. So I interrupted you. So what's tolerance then? Is the plus minus thing on cost more at a transactional level? Is that what that's about?
Is that, yes, the tolerance basically is at the project level or at the product level. It's like, you miss a target by 10% or 5% or whatever it is.
Yeah. Hopefully you got enough different differences that it averages out at some point. So another comment was Carl mentioned creative chaos. So how to be consistent in an inconsistent world. And I know that you have on the screen, or it's on your book title, VUCA, which is a nod to this just inconsistent world. So how do you create is this framework resilient enough to the ever-changing world we're in, which I think it is, and two, when the ISO themselves change it. So not only is our hopefully stable framework staying consistent, so we have a consistent process, but every 7 years it gets a hard look and says, oh no, we're going to change that again. So it's like we have the foundation changing under us, and the world all around us is changing all the time.
Yeah. I don't think we're ready for all the changes that are happening. And can we create order out of chaos? What we can do is create reasonable order around the chaos. And the reasonableness is actually going to be defined by use of the standard, and specifically understanding the context.
Hence a plug for next month.
Well, yeah, that's next month's talk, is understanding context.
Yeah.
A lot of what I would call newbies, when they're getting into this world, want to boil the ocean. And a good way to sort of understand if somebody's new to the world of risk is to see, how do they interpret how do they interpret context? How do they scope the project so that it's reasonable? How do they scope it so they get an answer that's good, but maybe not the best answer? Because the best answer might require more resources, more time. So what's good is good enough. And the pros in this world of reliability or quality, or what we're talking about, know when good is good enough, because they've met the reasonable threshold.
Yeah. So let me change gears here then. Jing Sung asked the question, we just got a couple minutes, is he was on the definition of risk. It's kind of early on when you're talking about is the uncertainty and achievement of the objective still sounds vague. Uncertainty really means something unknown. I don't know about that one, Jing Sung. Unknowns cannot really be evaluated. We evaluate all the probability of something we know. So from reliability perspectives, we consider risks identified. I'd rather consider risk identified factors that can lead to failures of an objective achievement. And don't know how much I could be right about this. I'm trying to think of how I can get this to you, because I might not be reading it as expected. So let me put this in the chat so you can see it. It's in the question. Well,
okay.
Can you see the chat now that you don't have your full screen?
Yeah, I'm looking at it right now.
There you go. This is Jin San's question.
Okay, the achievement of risk as uncertainty and on the achievement still sounds vague. Um,
Well, you're going to get into parsing the words and everything else, but I, from what you were talking about earlier, is that, and I agree with you. When somebody sets a reliability goal or sets a specification, it must be less than 5 pounds, or, you know, it's an objective. We want to make profit next year of X amount. That's a statement. It's you don't put confidence intervals on it. For example, it is what it is. Whereas and I think it gets to what Jin Sun's talking about, is that, you know, we might say we want to be 98% reliable for 2 years with this new product, yet there's uncertainty, plus or minus, of whether we can achieve that or not. And there's technical uncertainty, there's all kinds of stuff. At higher levels, then it's, you know, are we going to have sufficient profitability or whatever our objectives are? And so we're going to make decisions that affect that. And it's true, we don't know of all the factors and all the perturbations that can impact the ability to achieve that goal. You know, we know a lot about climate change, we know about supply chain disruptions, but we don't know where the next thing is going to happen to us that's going to cause problems or uncertainty. The issue is that you identify, I think part of the framework, and you didn't touch on it very much, is that that monitoring part it's the antennas are up looking for those indicators of uncertainty and change. So you can recognize when something's changing in an adverse or a opportunistic way, that you can respond to it in a timely way. The hard part is that the uncertainty of the risk of achieving the objective, that we can quantify. That ties right back to that risk appetite piece. You know, there's a threshold for ones that we want to deal with or not deal with.
Well, I think, you know, it's 9:59. I think we're going to, you know, every month I'm going to choose some topic in decision-making or problem solving. And I'll just simply outline the what do you call it, the boundary conditions of the problem. And then we'll have lots of fun sort of discussing it. What I recommend to folks is your personal differentiator, value add, is going to be your ability to problem solve and decision make. The machines are getting smarter, smarter, smarter. We're going to talk about that probably in December or November. And put risk as one of your core assets, you know, when you're going after a job or an opportunity.
Yeah. And it's your ability to deal with it, you know, to have lots of tools in your kit to not only identify risk, but then to mitigate or resolve or accept or whatever. It's all parts of the system. One that I talk about a lot is your ability to communicate, right? That's kind of the left-hand side structure of this framework, is you got to talk. You got to let people know what's going on.
Yep.
That's a big part of it. All right. So I grabbed 2 email addresses of people that wanted a copy of the slides. I'll forward that to you, Greg, so you can get it to them if you'd like.
Absolutely.
And then we'll have the recording up here probably in a day or 2, and we'll go from there.
Hey, thank you, folks. Thank you for your time. If you had questions or you think I suck, hey, I'm a grown-up. Send me an email.
Yeah. And well, thanks again, Greg.